Okay, so now we're on session 7. So now, after all this, after everything we have been through as people, as students of ECON 201, they kept changing this aggregate demand equation, kept changing it. First they assume it's this, then they change C, they broke up C, then they put tax, then they changed now I. But now finally, we have come as students to the final equation. And this over here, my guys, is the final equation which you're going to be used for the aggregate demand function. Right? So, if you watch my previous videos to get to this point, but yeah, this is it, right? What's new in this equation? Obviously, the fact that we have investment minus BI. We now know that investment is just not I alone, right? Unlike G, which is alone, unlike NX, which is alone. No, we've said that interest rate affects investment. So because there's an dependency relationship, we're going to now make I autonomous and put a induced. Autonomous are all that has hats. Induced is these ones, the no hats. So okay. So we got all our now this is your equation. Now remember, memorize this. Okay? In fact you just have to memorize this. And obviously this. But this you'll get from here. So if they give you all these variables in a question, which they do in the written questions, you'll know how to do it. How do you get from this to this, you might ask? See all the hats. What you're going to do is add all the hats up. You get that? So A hat stands for all hats. So all hats put together, obviously it's going to be a number, you could put it there. Then what's left? There we go. So that's how we get it, right? So just remember this equation, right? Now all of this is autonomous. All the stuff that is autonomous is put into A hat. All the stuff is induced. We have 1 over here and we have 2. This is your investment induced expenditure. This is your consumption induced expenditure. T is the tax rate. I is your interest rate. Y is your income. Just note, right? If they give you all the numbers and if they don't give you Y, that's completely fine. Because what's going to happen is this is going to be an equation. So A, you'll get an answer. You'll probably get 200 for A, or any number for that instance. This whole thing will turn into a number, probably like 0.3, and then minus BI. BI will also turn into a number, BI, but it depends on the income. But it might be, there we go. So like that's how you get your aggregate demand function, right? They can't give you the interest rate. If they give you the interest rate is 3%, obviously what you're going to do is simple. You're going to fill in all the values you got. So 3 times 3, don't put 0.03. Oh no, sorry. If they give you 0.03, you put it in your answer. But whatever they say I is, if they say in the question I is 7, you just put 7. If they say I is 0.07, you put that as that. So if they say I is 7, so if they say I is 7%, you're going to put 7. Then obviously you're going to work it out, and this will be your whole aggregate demand function. So you'll have a y over there in your aggregate demand function. Don't stress, because that's an expression. So you're going to have that, right? For this, refer to the textbook and all this equation, because they come out a lot of times. So you need to know how to turn what they give you into this. Okay. Now, if your interest, your I, if it decreases, can you see how this is a minus this? So obviously if this decreases, it's going to make your aggregate demand go up. And makes sense. If your interest decrease, there's going to be more investment. So I is going to increase. So I belongs in here. So obviously AED is going to increase. So if any side this increase, that's also increase. Okay. So in my previous video, I showed you, I didn't do it. I said we need to derive the IS curve, right? So how did we get this? This, by the way, is IS curve. Now they're not showing here, but they also have an LM curve. But they're not concentrated on that now. They just concentrate on the IS curve. How do we get the IS curve? Right. So if they give me my autonomous expenditure, so they'll be like autonomous expenditure is equals to 100. And they tell me during this time the interest rate was, they'll say B is equal to 2. Then they'll tell me each interest rate is equals to, let's make it simple. Let's make it 2 also. So what will be this value over here? It'll be 100 minus 2 times 2, isn't it? That will be 100 minus 4. That's 96. So this is 96. So now let's say interest decrease. So interest now has gone from 2 to 1. So how? So autonomous will be the same. It will be 100 minus the B will always stay the same too. But your interest now changes to 1. Now it's 98. Right? So keep in mind, I want you to keep in mind the interest because it's very important in deriving the IS curve. So your interest rate was 2, but it dropped down to 1. Your interest rate was 2% and it dropped down to 1. So anywhere in the height, right, put 2% and 1%, right? Anywhere, literally. And what you're going to do is, now, because the interest rate obviously decreased, your aggregate demand shifted up. So you're going to have 2 equilibriums, yeah? So match it over here and match it over here, right? Goes down, goes down. Straight away draw a dotted line hitting the x-axis over here. And then from the interest rate you got over here, remember 2% could be even here, 1% could be here, but as long as you put 2 above 1, this and you'll have to space. So all you do is just they hit it. So this line intersects with this line, draw a circle. This line intersects with this line, draw a circle. And can you see how if we ignore, okay, let's draw it. So you'll have basically a circle over here and a circle over here. You know the only way to make a line with the circle is to draw like that, literally. So that's how they got the IS curve. You see how simple it is. Now there can't be a curve going this side, obviously, because there's no way you can draw a line. So that's how they got the IS curve. So this is how in real life the IS curve is derived. So you see how that is what I say, it comes from the good market. And each point over here, each point means it where the goods market were in equilibrium. So the goods market equilibrium here and equilibrium here, it's going to be a point. So can you argue that every single point, even this point over here, I can argue this point over here, it's where the goods market is also in equilibrium. Because if I trace up that over here, I can make my aggregate demand decrease and it'll be like that. And this is anywhere on this gray line, it's in equilibrium. So any point on my IS is where the goods market can be in equilibrium. You see what I'm trying to mean? That is why when we join the LM curve, we say that both curves are in equilibrium. You see what I'm trying to mean? So yeah, that's the whole point of it. Okay, so now another way of, let's see. Okay, so basically, we can also derive the equation, or what they're trying to say, instead of looking at this y and bringing it down and touching here, you can get this, what this number is. To get that number, well, it's the same as this number over here. So to get this number, see this thing over here, it's associated with this equilibrium. So take this thing and multiply it with the multiplier. So the multiplier is 1 over 1 minus c times 1 minus t times this, right? So times this. That will give you this answer here. Be careful of how I put the brackets, and this is c times 1 minus t here, and all in that, because board maths will get it completely wrong. AG is the fraction. Yeah, it's the same thing I showed over here. AG times that. Short form is AG. This is called AG, means a multiplier. Yeah. The slope of the IS curve is very important. Okay, so if B is large, that will happen. Okay. So you know how our investment function is equals to autonomous investment plus, sorry, I'm only making this mistake, minus BI. So if your B is large, there we go, if my B is large. If my B is large, right, if it increases, sorry, if my interest rate decreases, my aggregate demand curve is going to be very steep, right? Can you see over here this line here and this line, how steep it is? Because this is associated with the big B. But see these lines over here, it's more like, smaller. That's associated with small b. But they don't usually ask about this. What's most important is this. A big B will be associated with a flat. They always ask us in test. IS curve. A small b, steep. IS curve. Also, IS curve, it could also be an investment schedule. In my previous video, I said big B, the flat investment schedule. Whatever the investment schedule is, the shape will also be this shape. So yeah, both of them will be flat when big B. Besides the actual aggregate demand curve, right? So this is flat. See this? So you can see this has a big B, and this probably has a small b, right? So yeah, and remember, if our multiplier is big, we're gonna be having a steep aggregate demand curve also. And obviously our y will change by a lot, because if you increase by 200 the autonomous expenditure, but your y increase more than that, let's say 400, that means your multiplier is 2, because 2 times 2 is 400. So the bigger the multiplier, what they're trying to say, if it was 4, it'll be 4 times 200, that's 800. The bigger the difference in the y's. So yeah, multiply is larger on the dash curves. I just showed that right now. Given a drop in interest, it goes up. I told you, interest drops. There's more investment, so AD will go up. Why? Because AD inside it has all that C plus G plus I, and one of them is investment. And when interest drops, investment will increase. So it'll make the whole aggregate demand shift up. As you can see over here, it shifts up. So ignore these dotted lines. Can you see how it just shifts up? Yeah, the shift, right? Any shift of the aggregate demand is caused by only the autonomous stuff. Like we saw, interest rate drops is part of I, so that causes it to go up. G, government spends $1 million, causes the AD curve to go up. So yeah, all that is autonomous. Change in Y. This is not actually change, it's net change. Some people get confused between this and this. This is like finding the derivative. This is net change. So what is the difference? If I say my income increased from 1,000 to 2,000, my net change is 2,000 minus 1,000. So how much it increased by? So they say income increased by 1,000. So let's put 1,000 instead of net change of Y. So your net change is Y is obviously going to be this, because like what it increased by. To find what it's increased by, you're going to take your multiply times the autonomous expenditure. So I told you, if you increase this by 200, so government puts in 200 in spending, you know it's going to be more than this. So 200 times your multiplier will give you the net change in Y, which is going to be like about 400 or something. It'll be more than that, obviously. So when I say 200 times a multiplier, sometimes you won't know what a multiplier is. So let's say 200 times 1 over, and you know this formula, 1 minus c times 1 minus t. And you get your answer. T is a tax rate, C is your MPC. Very important. MPC. If they give MPS like 0.8, your MPC will be 0.2, because MPS plus MPC is equals to 1. Marginal propensity to save, marginal propensity to consume is equals to 1. So they'll trick you over here. Watch out. And yeah, that's session 7.